The National Electrical Code, or NEC, mandates that metal water pipes emerging from submersible wells be grounded. This requirement extends to all non-current carrying metal parts of equipment. The primary reason for grounding is to establish a low impedance path for fault currents to return to the source. This ensures the operation of overcurrent protective devices, such as circuit breakers or fuses, in the event of a ground fault, thereby mitigating the risks of electrical shock and fire. The grounding conductor must be connected to the grounding terminal located at the service equipment. Proper sizing of the grounding conductor is crucial for its effectiveness, and the sizing must adhere to the specifications outlined in NEC Table 250.122. Table 250.122 dictates the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device in the circuit head of the equipment. For example, if the overcurrent protective device is rated at 60 amps, the minimum size of the grounding conductor is typically number 10 AWG copper or number 8 AWG aluminum. If the overcurrent protective device is rated at 100 amps, the minimum size is number 8 AWG copper or number 6 AWG aluminum. If the overcurrent protective device is rated at 200 amps, the minimum size is number 6 AWG copper or number 4 AWG aluminum. If the overcurrent protective device is rated at 400 amps, the minimum size is number 3 AWG copper or number 1 AWG aluminum. It is imperative to consult the most current version of the NEC to ensure compliance with the latest regulations and amendments. The 5 horsepower 3-phase 480 volt submersible pump, being located approximately 320 feet deep, necessitates a grounding system that can effectively handle potential fault currents associated with such a powerful motor. The metal water pipe provides a convenient and often readily accessible point for establishing this ground connection. The NEC specifies acceptable methods for making grounding connections, emphasizing the use of listed grounding clamps or connectors suitable for the materials involved. These connectors must be properly installed to ensure a reliable, low-impedance connection to the grounding electrode system. The grounding electrode system typically consists of one or more of the following: a metal underground water pipe that is in direct contact with the earth for 10 feet or more, a ground ring encircling the building or structure, a rod or pipe electrode, or a plate electrode. The metal water pipe often serves as a primary grounding electrode, supplemented by additional electrodes as needed to achieve the required grounding resistance. Grounding resistance is measured in ohms and represents the opposition to the flow of current to ground. A low grounding resistance is essential for effective fault current dissipation. The NEC recommends a maximum grounding resistance of 25 ohms for a single rod, pipe, or plate electrode. If this resistance cannot be achieved, an additional electrode is required. When using a metal water pipe as a grounding electrode, it is important to bond around any insulating sections or joints in the pipe to maintain electrical continuity. This bonding is typically accomplished using a copper bonding jumper sized according to Table 250.66, which specifies the minimum size of bonding jumpers based on the size of the service entrance conductors. The connection of the grounding electrode conductor to the metal water pipe must be made within 5 feet of where the water pipe enters the building. This requirement is intended to minimize the impedance of the grounding path and ensure effective fault current dissipation. In addition to grounding the metal water pipe, it is also important to ground the metal casing of the submersible pump motor itself. This grounding is typically accomplished using a separate equipment grounding conductor run with the circuit conductors supplying power to the pump motor. This equipment grounding conductor must be sized according to Table 250.122, as previously mentioned. The connection of the equipment grounding conductor to the pump motor casing must be made using a listed grounding lug or connector suitable for the application. It is also important to ensure that the well casing itself is properly grounded. Although the question specifies that the well casing is PVC, which is non-conductive, there may be other metal components associated with the well casing, such as metal reinforcing bands or a metal well cap, that require grounding. These metal components should be bonded to the grounding electrode system to prevent them from becoming energized in the event of a fault. The NEC also addresses the issue of stray currents in electrical systems. Stray currents are unwanted electrical currents that can flow through the earth or other conductive materials, causing corrosion and other problems. Proper grounding and bonding practices can help to minimize stray currents. The NEC requires that electrical systems be designed and installed in a manner that minimizes the potential for stray currents. This includes using insulated conductors, minimizing the length of grounding conductors, and ensuring that all metal parts of the electrical system are properly bonded together. Regular inspection and testing of the grounding system are essential to ensure its continued effectiveness. Grounding resistance measurements should be taken periodically to verify that the grounding resistance remains within acceptable limits. Visual inspections should also be conducted to check for any signs of corrosion or damage to the grounding conductors or connections. If any problems are detected, they should be corrected promptly to maintain the integrity of the grounding system. The grounding system is a critical component of the overall electrical safety system. It provides a path for fault currents to flow back to the source, helping to protect people and property from electrical shock and fire. Proper grounding practices are essential for ensuring the safety and reliability of electrical systems. It is always recommended to consult with a qualified electrician or electrical engineer to ensure that the grounding system is designed and installed in accordance with the NEC and other applicable codes and standards. Neglecting the proper grounding of the metal water pipe from a submersible well can have serious consequences, including increased risk of electrical shock, equipment damage, and fire. Therefore, it is imperative to adhere to the NEC requirements for grounding to ensure the safety and reliability of the electrical system. The NEC is updated every 3 years, so it is important to stay current with the latest edition to ensure compliance with the most recent regulations. The NEC is a comprehensive document that covers a wide range of electrical safety topics, including grounding and bonding. It is an essential resource for electricians, electrical engineers, and anyone involved in the design, installation, or maintenance of electrical systems. Proper grounding and bonding practices are not only required by the NEC but are also essential for ensuring the safety and reliability of electrical systems. By following the NEC requirements for grounding, you can help to protect yourself, your family, and your property from the hazards of electricity. Remember, electricity can be dangerous, and it is always best to err on the side of safety. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical engineer. They can provide you with expert advice and guidance to ensure that your electrical system is safe and compliant with all applicable codes and standards. Grounding is not a one-time task, but an ongoing responsibility. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. This includes checking for any signs of corrosion or damage to the grounding conductors or connections, as well as verifying that the grounding resistance remains within acceptable limits. If any problems are detected, they should be corrected promptly to maintain the integrity of the grounding system. Grounding is a critical aspect of electrical safety, and it should never be overlooked. By understanding the NEC requirements for grounding and following proper grounding practices, you can help to protect yourself, your family, and your property from the hazards of electricity. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about electrical safety. Their expertise can help you ensure that your electrical system is safe and compliant with all applicable codes and standards. Grounding is more than just a code requirement, it is a fundamental principle of electrical safety. It provides a path for fault currents to flow back to the source, allowing overcurrent protective devices to trip and to energize the circuit, thereby preventing electrical shock and fire. A properly grounded electrical system is a safe electrical system. The NEC provides detailed guidance on how to ground electrical systems effectively, and it is essential to follow these guidelines to ensure the safety of people and property. Grounding is not a simple task, and it requires a thorough understanding of electrical principles and the NEC requirements. If you are not familiar with grounding practices, it is best to consult with a qualified electrician or electrical engineer. They can provide you with the expertise and guidance you need to ensure that your electrical system is properly grounded. Grounding is an investment in safety, and it is an investment that is well worth making. By properly grounding your electrical system, you can help to protect yourself, your family, and your property from the hazards of electricity. The 5 horsepower submersible pump operating at 480 volts represents a significant electrical load, and any fault condition could result in substantial current flow. The 320-foot depth of the well increases the potential for insulation breakdown and subsequent ground faults. Therefore, adherence to NEC grounding requirements is paramount in this scenario. Firstly, the metal water pipe must be grounded using a grounding electrode conductor connected to the grounding electrode system. Secondly, the size of the grounding electrode conductor must comply with NEC Table 250.66, based on the size of the service entrance conductors. Thirdly, the connection to the metal water pipe must be made within 5 feet of its entrance into the building and before any insulating joint. Fourthly, bonding jumpers must be installed around any insulating joints in the metal water pipe. Fifthly, the submersible pump motor itself must be grounded using an equipment grounding conductor run with the circuit conductors. Sixthly, the equipment grounding conductor must be sized according to NEC Table 250.122. Seventhly, the welt casing, if metallic, must also be grounded. Eighthly, regular inspection and testing of the grounding system are essential to ensure its continued effectiveness. Ninthly, any problems detected must be corrected promptly. Tenthly, consult with a qualified electrician or electrical engineer for guidance. The NEC mandates a comprehensive approach to grounding to minimize the risk of electrical hazards associated with submersible well systems.